Science Journal for Kids and Teens presents How Do Storms Impact Coastal Ecosystems? Read by Miranda Wilson. Abstract. Climate change is making tropical cyclones stronger. It is also making them more common. We know tropical cyclones can cause a lot of damage to houses and buildings, but what about coastal ecosystems? We depend on coastal ecosystems for protection and food. It's important to understand how increasing storms could impact them. We collected data from the literature on 97 storm landfalls. We looked at things like death and diversity. Then we calculated the impact on 5 different coastal ecosystems. We also looked at what caused the impact, for example, wind or waves. We found that tropical cyclones harmed all 5 ecosystems, but they harmed mangrove forests the most. Mangrove forests were most often harmed by wind. We need to know more about what storm traits can cause impacts. Only then can we manage and preserve these ecosystems better. Introduction. Have you ever had to evacuate your home because of a storm? The storm was likely a tropical cyclone. You might know them as hurricanes, typhoons, or just cyclones based on where you live. Tropical cyclones are rotating storms that form over the ocean. We classify them based on their wind speed, categories 1 through 5. Categories 4 and 5 are very intense. They can have wind speeds of more than 130 miles per hour, or 209 kilometers per hour. Tropical cyclones can cause billions of dollars in damage to property, but we don't always think about the damage they can do to coastal ecosystems. Tropical cyclones can hurt organisms and habitats. For example, big storms can break coral or uproot mangrove trees. Tropical cyclones can also cause sediment to move. They can even change the water quality. We depend on many coastal ecosystems. They give us food and protect coastlines from storms. They also give us beautiful places to explore. Researchers know that climate change can make tropical cyclones stronger and more common. Unfortunately, it is hard to predict their impacts on ecosystems. Coastal ecosystems are very complex. In the past, researchers have used wind speed to predict damage, but that may not work for every type of coastal ecosystem. We wanted to find out what impact tropical cyclones have on different types of coastal ecosystems. With this information, we can start to predict the impact of storms on our coasts. This will help us manage those areas better. Coastal ecosystems provide food, coastline protection, and beauty for people. In this image, you can see some coastal ecosystems. From left to right, they are A. Oyster reefs, showing oysters on the half shell. B. Coral reefs, showing a clownfish and anemone. C. Salt marshes, showing a channel with salt marsh grass on either bank. D. Seagrass meadows, showing grasses in shallow water. And E. Mangrove forests, with their roots exposed on the beach at low tide. Methods. Impacts on ecosystems. We searched existing studies for North Atlantic tropical cyclones that made landfall. They also needed to have information about their impact on coastal ecosystems. We found records for 97 landfalls. These had 891 separate data points about impacts. We explored data from 5 different ecosystems. They were mangrove forests, seagrass meadows, salt marshes, oyster reefs, and coral reefs. We looked at data like animal growth and death. We also focused on things like diversity and food web complexity. Then we calculated the effect size. We used pre- and post-storm data from the research to do this. Causes of impacts. We looked at the research studies to see what was causing impacts. This included wind, waves, sediment movement, changes in salinity, and storm surge. We also looked at how often they occurred. Results. We found that tropical cyclones harmed all the ecosystems. The largest impact was on mangrove forests. Here in Figure 1, you can see the effect sizes in the 5 coastal ecosystems. Negative effect sizes show harmful impacts from tropical cyclones. On the x-axis of the graph, you can see the 5 coastal ecosystems. From left to right, they are oyster reef, seagrass meadow, salt marsh, mangrove forest, and coral reef. Each are represented by an appropriate icon. The y-axis shows the effect sizes. A dashed line at 0 indicates no impact on the ecosystem. Impacts in each ecosystem had different causes. For example, damage in mangrove forests related to wind speed, but damage to coral reefs was because of waves. Here in Figure 2, you can see the causes of damage to each of the different ecosystems. The size of the icon represents the amount of damage. Across the bottom, the ecosystems are mangrove forest, salt marsh, seagrass meadow, coral reef, and oyster reef. The icon for mangrove forest is larger than the other icons. Above each icon is an arrow showing the cause of damage. For mangrove forest, damage is caused by wind. For salt marshes, damage is caused by storm surge. For seagrass meadows, damage is caused by sediment movement. For coral reefs, damage is caused by waves. And for oyster reefs, damage is caused by salinity. Wind speed defines the strength of tropical cyclones. How many coastal ecosystems suffer damage mainly from the wind? Which one or ones? Discussion. Our results show that tropical cyclones cause damage in all the ecosystems we looked at, but different things cause damage in the different ecosystems. For example, mangrove trees have exposed roots and branches. Our data showed that mangrove forests were most affected by wind speed. Wind damaged branches and uprooted trees. In contrast, seagrasses and salt marsh plants are flexible. They can bend in the wind and waves. We found instead that they were most affected by sediment moving and storm surge. In fact, we found wind caused most of the damage in only one of the 5 ecosystems. Wind speed defines the strength of tropical cyclones. Our results show we cannot rely only on wind speed to predict damage to coastal ecosystems. We need to know more about things like wave action and sediment movement. We also need to know more about water quality and storm surge. Many coastal ecosystems are quick to recover from storms, or resilience. Others can resist damage in the first place, resistance. Climate change will cause more intense and frequent tropical cyclones. This could decrease the resilience and resistance of coastal ecosystems. But people depend on these ecosystems. So, better management of these areas is essential to help them weather the coming storms. Conclusion. Coastal ecosystems provide us with food, as well as protection from storms. They are also beautiful. As storm impacts increase, there are still things we can do to protect them. Reduce pollution by reusing and recycling things. Write letters to your local council or representative. Explain why we need to protect coastal areas from development. Support or volunteer with local habitat conservation efforts. And decrease your contribution to climate change. Ride your bike or take the bus instead of driving. Thank you for listening to this recording. This work has been adapted from the original peer-reviewed paper in the journal Communications, Earth and Environment, published on November 8, 2024. Research conducted by Colette J. Feehan, Karen Philby Dexter, and others from the Department of Biology at Montclair State University in the U.S. and the UWA Oceans Institute and School of Biological Sciences at the University of Western Australia in Australia. See the full list of authors and their affiliations in the accompanying PDF. Please visit our website, sciencejournalforkids.org, for more free science teaching resources.